Hello, welcome everybody. This is the session on mobile applications in citizen science. I'd like to invite Ulrike Sturm first to join me on stage if I could. Ulrike, would you like to introduce a little bit what the aim of this session is, please?
Hi. Yeah, I would like to introduce this session because we started with this whole discussion on apps and platforms in citizen science in 2016 with a workshop in Berlin where we discussed principles for apps and platform development for citizen science, and continued this discussion in 2017 in Gothenburg. And we thought it would be a great opportunity to use this EXA conference to continue talk about it and to reflect a little bit more on the untapped potential that apps and citizen science have, but also to talk together about barriers and failures, and in the end, how we could overcome these barriers together, and how we could look together in the future of apps and citizen science.
Fantastic. Thank you, Ulrike. That's the scene in a very nice way. We have two case studies that are going to be presented as part of this session. If Steve could join me on stage already, please. Stephen Richardson is from the British Geological Survey, and he's going to tell us a little bit about using citizen science mobile phone technologies in St. Vincent and the Grenadines to facilitate real-time multi-hazard observations. Over to you, Steve.
Hello, thank you very much. So yes, I'm Steve Richardson. I'm a geospatial application developer at the British Geological Survey. So I'd like to talk a little bit about the work we've been doing over the last 3 years in St. Vincent and the Grenadines, using mobile phone technology to create the MyHazard platform. So in terms of a bit of context, St. Vincent and the Grenadines is an island chain in the Eastern Caribbean. There's maybe about just over 100,000 people, and they're affected by a number of serious hazards, natural hazards. So being a part of the Eastern Caribbean, hurricanes are a big risk each year. Flooding, landslides, particularly on the island of St. Vincent with the steep terrain. Earthquakes, and there's also a large volcano, Le Soufriere, in the northern part of St. Vincent. There's also tsunami risk. So there's a lot going on, there's a lot of risk in the area. So BGS has been working with our partners in the country and also the region to develop this system. So we're working with the National Emergency Management Organization, NEMO. So they're the organization who's primarily responsible for preparing for, responding to, and recovering from these natural events. And also we're working with our partners, the University of West Indies Seismic Research Centre in Trinidad, who provide scientific expertise and advice to governments in the region on volcanoes, earthquakes, and tsunamis. So we've been doing work with our partners, and our project goals have been really to increase the resilience of St. Vincent and the Grenadines to these natural hazards through the use of citizen science. So we're aiming to improve the communication between individuals and communities and also decision makers, to improve the ability to make decisions and actionable information by anticipating events, encourage collaboration between community groups and decision makers, increase the awareness and amount of information that's available on these natural hazards, and also to generally improve the decision-making process between, and that's whether it's on an individual level or whether it's on an organizational level. So over the 3 years, we've done multiple stakeholder engagement workshops with the community to help co-design this application. And we've identified a number of key features which were kind of recommended that this tool would need to meet. So including real-time data validation. So this is in order to make data as accessible as soon as possible after an event or an observation's made, in order to make decisions on a timely basis. Emphasizing multi-hazards, so not just focusing on one particular type of hazard, not just homing in on earthquakes, for example. Making hazard advice available and accessible in an easy way, where mobile phones are ideal, having information in your pocket like that. And also any system needs to have some ability to work in a network poor environment where perhaps there's some offline impact. So together we've co-designed the system called MyHaz VCT, which is a platform for St. Vincent and the Grenadines. And it's got 3 key components. So it's got a smartphone app, which is primarily for collecting hazard observation and submitting it through to authorized users. There's the MyHaz Manager, which is a dashboard application for authorized users in order to receive the observations and to validate them and communicate with submitters and citizen scientists as well. And we've also got a portal, which is a separate application for visualizing and making all the data publicly accessible for visualizing and exploring. So I'll briefly talk about each of these elements and what they do. So MyHaz, the app, is a cross-platform application for iOS and Android, and it has 3 key modes. So starting on the left is the hazard activity screen. So this is a heads-up display about the number and types of hazards which have been reported across the country, which lets users then go and explore and learn more about where they've been identified. And also to visualize the common alerting protocol alerts, which is a standard system which St Vincent already uses to notify their citizens of any hazard events ongoing. So the app just taps into that to republish it. So the meat of the application is adding an observation. So this is where users will identify a hazard, select the most appropriate category, and then answer a number of short questions. First of all, where is it, whether it's using on a map or the GPS of the device, a free text description, and then a photos or some videos. So that's the minimum observation that's required. But there's also, we've co-developed some extra questions which are specific to the types of hazards which the scientists have helped develop, which can add some extra context and flavor around the observation, which will be really useful for people making decisions once they receive this information. And lastly, there's a map-based interface for visualizing all the observations on the map. The map is also available offline, so when there's no network, this application still works. And this lets users visualize and explore the observations submitted and comment on other users' observations. So the second part of the tool is the management tool. So this is a web-based application for visualizing incoming observations and allows the authorized users to see the information that's been submitted, see the pictures and videos, and be able to respond directly to the user that submitted it, and also to provide a publicly accessible comment on what action might have been taken based on that information. And lastly is the portal, which is a web GIS application that allows free access to all the observations submitted over time to let people filter, explore, and download into an offline format for further analysis in a GIS. So in terms of the back-end architecture which the system runs on, so the applications themselves are all developed using web-based technologies, in which this case they're using Angular. And the apps themselves also using Angular, but they're using a cross-platform technology called Apache Cordova to wrap the applications so we can deploy them to an iOS and also to Android applications. The benefit of having one coding language is we can share developer resources and skills in order to have much more output with limited availability. In terms of the back end, we're using a system called Docker to containerize each of our components of the application. So whether this is GeoServer, which provides WMS layer access to the different platforms, whether it's Minio for the media store or a custom tile server, it's all packaged up neatly using these Docker containers, which gives us a lot of control about what platform it ends up being deployed onto. So over the last 3 years, we have learned a lot, and there's definitely been successes and challenges along the way. So we've been very lucky with the team and stakeholders and the partners we've been working with, because we've had great local links that BGS has had over the years that we've been able to really give us a foot in the door and able to make those connections with community groups, volunteers, other kind of projects that are ongoing. So when we're gathering feedback, we're not coming out from the outside so much. It's been really useful. Simple things like having a WhatsApp group in St Vincent and the Grenadines, that's the key way people communicate with each other. So having that as a way of testing beta versions of the app in order to gather feedback on a very low level in really quick way. It's something we should have probably done sooner, actually. So it's both worked well and also a challenge. And working with the Seismic Research Centre right from the beginning, we've been able to really leverage their support and experience. So, for example, the director of SRC, Professor Robertson, is from St Vincent and the Grenadines, so he has had local contacts, which has just been invaluable. In terms of challenges, so designing a system for collecting citizen science information that's both intuitive and simple and quick, while on the other hand also can have the potentiality and the flexibility to collect large amounts of specific scientific hazard-related data. It's a bit of a challenge trying to find a balance, and we can always improve. Secondly, people are really busy. So having people come in stakeholder engagement workshops or community visits, it's a time-consuming process for them. So being able to make sure that we reward their time and effort and feedback and value and show value for what they're giving back to the project and showing that it's worthwhile for them is always something we can improve on. And lastly, in terms of BGS and the funding and the kind of development cycle, it's over 3 years, which is a longer period of time than perhaps people and users might be expecting. So being able to manage the expectations of users, or when the system is coming out, when's it being tested, is something that we can always improve on. In terms of the technologies, having a shared code base to work on multiple applications has been invaluable. So we've been able to share same developers, code bases, able to write code for one application and redeploy it onto another one. It's been really key. In terms of the backend, using Docker has allowed us to modularize the backend in order to make it much more flexible. We can swap components in and out which don't break others, so that's been really useful. And making sure that one size doesn't fit all. So yes, we can develop an app, but an app is not the best place to have validating observations for that being submitted or for providing public access to data, which is why we ended up with a system which has an app for collecting, a manager tool which is on a large screen, and also a portal for public access, because they've all got different purposes and they've all got different strengths on different platforms. In terms of challenges, we're using cross-platform development. So yes, we're using the same code base across all the different applications, but it doesn't solve all the problems. There's idiosyncrasies with the technologies, specific hardware, specific software. So it's worth bearing that in mind. From the beginning, it would have been ideal if we'd had our source code open sourced in something like GitHub. 3 years ago was a slightly different landscape for development. So whether we started the project today, whether we'd be in a situation to open source it from day one, it's a question. And lastly, testing hardware. BGS is primarily developing the application in the UK, so it's not always possible to go out on-site visits into the Caribbean in order to test in different environments, different weather conditions with different hardware and software. So that's why having local volunteers, local community input throughout the process is integral, and we can always do better. And lastly, in terms of the UI and the user experience, we had a single style guide which we were able to develop by a UX team in-house, which meant that we could make changes to the interface from a single point, and then it would be cascaded to the multiple applications. The application itself is using standard interface components like cards in order to make it a much more familiar experience for users, so not having to relearn this application. And we're happy that we've been able to use things like notifications, push notifications, in order to inform users when an observation they've submitted has been validated, or whether another user has commented on it, in order to nudge that engagement that their contribution is still being used and it's having an impact on others. In terms of challenges, the UX or the user interface was primarily designed in the UK by our design team. So there has been ad hoc opinions that perhaps it's a little bit too plain, a little bit too neutral. So there's a challenge or a question of how you get not just scientific and technical input from our partners at all stages, but also to get design input is really important. And in terms of the hazard observation submission process, the challenge is always to make it simple as possible, but also to provide as much information as is relevant and desired by the partners and stakeholders. So that's something that can always be improved. And in future, it would be great to be able to have more metrics, more analytics, in order to understand where we're failing our users, where we're not meeting their expectations, and how we can improve for future. So there's lots of people who have worked on this project over the time. So thanks goes out to everyone there. Thank you very much. I think we take questions at the end.
Well, you've actually done a brilliant job with your time there, Steve. So we do have time to take a quick question. In fact, Laura had 2 questions for you. I think you've answered the first question in part. The question was about developing the management tool, whether you developed it completely from scratch or if it was based on a pre-existing infrastructure.
It was completely from scratch. So there's benefits and disadvantages. The ideal situation is you take an existing platform and then you can modify it, and that's how, in an open source environment, that's where everyone benefits, if you can take an existing system and then add new value to it. When we started this application 3 years ago, we had quite specific requirements that meant that we had to develop it from scratch, which is why having things like a shared code base, having a shared design guide, meant that we could optimize the resources we had available and be able to make changes very quickly. So the management tool at the early stages, when we had workshops to present it and talk through the feedback, is quite different to how it is now, and because we've had the flexibility to either take components out or add some completely new functionality in afterwards. So it's, yeah, whether we would do the same thing as of starting the project now is a valid question, but yeah, we rolled our own for this one.
Thank you. And the second question was about your use of WhatsApp with the testing group. Could you say a little bit more about how much that was used and whether that helped to build trust with between the volunteers and the scientists?
Yeah, so one of the leads in the project, Anna Hicks, she's had a lot of work in the community, and she's done lots of work there. And when she's lived there, her primary means of communicating and contacting people out in the different communities in the various parts of either St. Vincent the Island or across other islands was through WhatsApp. So it was personal experience based on, well, this is how, if I was there, this is how we communicate with people. And when we've gone out into communities and talked to people and asked what's the best way to get your feedback later on, if we want to give you a beta version of this app, how's best to contact you? Is it email? Is it we send you, the kind of the classic ways? And WhatsApp came up time and time again. Everyone whipped the phone out in a beat. They typed the telephone number in. There you go. I'm in the group. No questions. It was just a natural evolution of it. And I wish we'd almost done it sooner rather than later. But yeah, absolutely recommend it. I mean, it's just how people communicate there.
Sounds like a classic case of going to where people already are instead of forcing them to come over to you. Thank you very much, Steve. That was a really fantastic presentation of that project. Next, I'd like to invite Friederike onto the stage. Friederike comes from the German Aerospace Center at the Institute of Data Sciences, and she's going to do a two-part presentation about the next case study together with Sicco Bauer from the Deutsches Geoforschungszentrum. They're going to tell you a little bit about their use of mobile applications in a citizen science project called Nachtlicht-BÜHNE. So Friederike, over to you.
Yes, welcome everybody. So I'm going to present lessons learned and insights from our project Nachtlicht-BÜHNE, and I'm very happy that I don't do this alone, but with Sicco Bauer, who is one of our citizen scientists involved in the project, and he will share his experiences with the project in the second part of the talk. Nachtlicht-BÜHNE, all about development of a code or co-design processes for mobile app development with scientists and the citizen scientists together. And we did this in 2 pilot studies where we created mobile applications, or currently creating mobile applications for specific purposes. So it's one application for the reporting of meteors and one for the identification of light sources. And citizen scientists are involved in almost all phases of the app development process, so in requirements analysis and the conceptualization of the app, and as well as the design, and also in the design planning and the organization of the field campaigns, which are used later on to test and evaluate the application. And the citizen scientists are not just involved in the app development process itself, but also in the design of the co-design process at the end and the reflection of this whole process. Yes, as I said, we have 2 pilot studies focusing on specific mobile applications. So one is about the identification of sources of light emission, which are the cause of light pollution. And Sicco will tell you a bit more about this in a few minutes. And the other mobile application is or allows people to report meteor sightings, especially fireballs, which are quite bright and large meteors. And those reports help scientists later on to learn more about the origin and the genesis of comets and asteroids, which are the sources of those meteors. And I'd like to tell you a bit more about the meteor application. So in order to, or the scientists need quite a number of information about those meteors once you see it, especially, of course, when you are at which place, and particular in which direction, and from where to where this object moves, because this helps the scientists later on to, for instance, determine the flight trajectory of the object. And it's quite important for the scientists that we have several reportings of the same object from different perspectives. So it's quite important to get a number of people involved that report those sightings. And also the information that people report needs to be very timely and precise in order to scientifically use the data that are collected. And that's why we thought this would be a good use case for our project. Because it's quite important to involve the citizen scientists and their requirements early on in the design of the mobile application. I'd like to tell a bit more about the co-design process that evolved for the Meteor application so far. There are basically 3 parties involved. So what you see on the very left is the citizens and the scientists that continuously are generating requirements and ideas for the design of the mobile application. And on the other side, we have the development team. So it's a student development team constantly implementing those features in the mobile application, which is a web app and which is online available for testing for everybody and giving feedback early on. And we regularly meet with the citizens and the scientists in online meetings where we discuss new features and also requirements. And once we have consensus about a feature, then it's given to the development team to implement it. And we have quite a number of different documents where we collect, for instance, requirements. At the very beginning, we had kind of a mediator in between that somehow translated the very high-level requirements of the citizens and the scientists into something technical that the development team could use to implement it. As it turned out, over time, we found a common language, and now both the student development team and the citizens and the scientists meet together actually in those regular online meetings. How did we do the requirements analysis? So we started actually with 2 things. So from the scientist perspective, we were interested in what kind of information they required about the meteor observation and also in which quality. And those information were collected in a document. And on the other hand, we together with the citizen scientists, we came up with, let's say, a number of user types. So for instance, the expert reporter or a completely novice in reporting fireballs. And we collected very high level requirements. So what those people want to, kind of features they want to have of the application and why. So for instance, we found out that novice users would like to have feedback whether other people also noticed and reported the same event, because that somehow confirmed them in their own observation. Later on, we broke down those high-level requirements into, let's say, more specific features of the mobile application, and those features are continuously updated and discussed within the group, so in this online meetings. And once a consensus has been built, those features are implemented and then can be tested and given feedback about continuously. The design process followed a similar process. So also worked with collaborative documents where people were able to post their design proposals that they created on the computer or with pencil and paper, and then just upload it as a photo, and we discussed those. One feature that we very heavily discussed, you can see on the right side, it's about how we can report the flight trajectory of the object that we observe on the sky very, let's say in a very intuitive and fast way. As you can see, we came up with basically two types of interfaces that the mobile application is offering. So one with a horizon view, and one with a Senate view. Yeah, what are the major lessons learned? So, yeah, when citizens and scientists work together, they somehow can take over the perspective of the other party, and this generates, at least to our experience, very innovative ideas that we would never have came up with when we work just alone as scientists. But this process takes time because you need to find a common language, and also, of course, you need to discuss very extensively some of the features. In terms of software development, it's sometimes an issue to have somehow synchronize the work of the ideation that is done by the citizens and the scientists and the software development. So once the citizens come up with a feature, they want to have it immediately implemented by the software development team, but sometimes this takes time, of course. And on the other hand, you don't want to have your software development team running idle while people heavily discuss about the feature. Yeah, and very last maybe. So both citizens and scientists, think very big at the very beginning of the project, and once the project is running, of course, you encounter that there are some borders. So it's the funding period, of course, the amount of funding, also technical restrictions that you have, and I think it's important to find a good balance between raising too high expectations at the very beginning, but also between killing good ideas right from the beginning. Yeah, and with these words, I hand over to Sicco.
Fantastic. Thank you, Friederike. Sicco, can we have you join the stage? Over to you, Sicco.
Hello. Can you hear me?
Yes, but we don't see your slides yet.
Yes, I cannot share them, unfortunately. I do not know what's wrong here.
Are you seeing the share screen icon at the bottom of your view?
I clicked it, but nothing happens, unfortunately. Maybe Friederike can share their slides. They are integrated, and I will say just next slide because I'm having technical issues, unfortunately.
Okay. Could we have Friederike added back to the stage, please, and then she can share her slides and Sicco will walk through them.
So I try. Just let me switch to the right position. Okay, here we are.
Great. Okay, Friederike told us something about that meet you up. My name is Sicco Bauer. I'm a citizen contributing to the light up, I will call it so. And the main question we like to answer is what illuminates the night? Well, you as a Harry Potter fan know it's lumos, but there's more, right? To answer that, we have to categorize different light sources, localize and count them, store and analyze the result, and we have to do this for a pretty large area. We are talking about 2 square kilometers. So we need a mobile app to do so. There is none yet, so we have to develop one. Next slide, please. First challenge is everything counts. The question we like to answer is what different type of light sources are there? So when you take a closer look to this these 2 photographs we have here from city scenes, there are different ones like windows, street lights. Right hand side you can see like advertising signs. There are lamps on the street, lamps on the staircases, and so on. Besides that, what else matters? When you take a closer look to the left-hand picture, you see windows, but they are different, right? For instance, some are much brighter than the others. The sides of the windows are also different. Some are smaller, some are larger. The color is very important for us. Some are white, some are more yellowish. You can even see a bluish one. So when we first went out and met with our citizen scientist group, we went down the street, we counted the signs and the lights, better said, and everyone came to another result, which was very interesting to us. So we have to need a common approach. Next slide, please. One of the cornerstones of our citizen science project is the data collection and acquisition form, as it's really important to get reliable and consistent data. So what we've done here, multi-stage iteration process, we went through firstly going out and collected the lights we see, then we said this is a category A, B, C, and so on, and then we iterated this. Of course, we have another version of our form, go outside again and back and forth, so we took like three or four iterations. And furthermore, we have spin-offs in form of online surveys because there were different questions which are really complicated to us. For instance, the window question, like how big is a window? And so we took photos, asked different people, what light sources do you see here? What do you can count? And so on to get an reliable data form. Next slide, please. I will go through my insights and lessons learned. First of all, it's a unique opportunity. I already participated in multiple citizen science projects, but this one is the first one I can actually take part in the co-design process. I've been involved in all stages of the process, and I have the strong impression that my opinion matters. It's fun to contribute, but it's also very time consuming. Please keep in mind that I have a completely different job. I'm not a scientist. So when we met, it's my spare time. It's in the evening times. And this is also more workload for our scientists. I came to the conclusion that IR scientists are really highly engaged, and I guess they have to be very passionate about it because it's a ton of load of work, more to do for them, and they have to be passionate to motivate people to work together with them. And I think that we are a large and great team. Last slide, please, for me. Okay, what are the final thoughts? I think both sides can benefit from a co-design approach, but it is a challenge in multiple ways because one have to collaborate in larger teams. So scientists have to take knowledge and skill in project managing, for instance. It's a higher workload for them, and obviously we are all currently obstructed by COVID-19. We, as I told you, the project is running since July 2019. We have been once met in the city of Jena in real. But since then, we didn't have the possibility. We wanted to do it again, but we can't. So all we are doing is online meetings, like the tents we have in this Nachtlicht-BÜHNE yet, and this is ongoing. And last but not least, I want to say that this specific scientific job can only be done in cooperation with citizen scientists, because the area we like to measure is really large one. Okay, thank you.
Fantastic. Thank you so much, Sicco. Great to hear the experience of a participant in the whole process as well. That's really lovely to hear your side of it and how successful it sounds like that was. We have quite a few questions for both Sicco and Friederike. I'm going to choose just a few so that we have time still for two more speakers in the session. But if we've got a little bit of time at the end, I can come back to those. So first of all, I've got a question for Friederike. Does the global network share processes like app design processes?
Sorry, I did not get the question.
You talked about global networks and the process that they share. Do they also share app design processes? Is the question.
Which global network?
I'm not able to go back to the asker of the question, I'm afraid. Maybe the asker of the question could add a little bit more detail there while we wait for that. One of the other questions was, how do citizen scientists record the trajectory of the meteors? From the slide that you showed, it wasn't quite clear how they actually record the trajectory. Can you say a little bit more about how the trajectory is recorded?
Yes, basically we have two views, as I mentioned. The horizontal view, where you actually see the area of the sky that you see when you observe the meteor, and the first thing you do is you need to indicate your viewing direction, which you can do via a compass if you directly observe the meteor. But if you do it later on, you need something for orientation, right? That's why we came up with certain features. For instance, we show the position of the sun and the moon as an orientation, and also the position of nearby cities. And the next thing is then that you enter the movement of the meteor, and you can just do this with 2 clicks and just indicating the movement from A to B as you see it on the sky, which is a nice feature. You can do this very quickly and hopefully also very precise, and this is something that we will evaluate later on.
Fantastic, thank you. There's also a question about the synchronous moments in the design of the application, and the question is which other tools you used for the code design process.
So actually, we worked with a mailing list to communicate. Then we have those virtual meetings. Therefore, we used tried with several video conferencing tools, as I guess everybody during the Corona times. And then we mainly working with Google Documents, basically, which are very flexible. And you can organize them in the way you want it. And that was sufficient for us.
Ah, fantastic, thank you. So a question for Sicco.
Mm-hmm.
There's a comment about that it was really interesting that both developers and the citizen science team managed to find a common language in the project. Do you think that the moderator was essential to building that shared language at the beginning of the project, the beginning of the co-creation?
No, I don't think so, because we didn't have one. So we jumped in cold water and have to find a common language. Actually, it was quite interesting because we didn't know what let's say other side was expectations. I did not know what the scientists have in mind and what are their goals, and they did not know exactly why we want to contribute, because we were really involved in early stages of this process. So that was really good. But I guess it's not a big issue here.
Okay, and perhaps for both of you, there was interest in how the push notifications worked, the in-app push notifications, and whether this was something important to encourage participants, and whether it was personalized or whether it was something more general, like a thumbs up after each report, and was it alerting citizen science to specific occasions? Can you tell a little bit more about how the push notifications in the app worked?
The push notifications are not implemented yet. It was requested actually by the citizen scientists as a very important feature. As I mentioned, they would like to be informed if other people observe the same event, because that somehow confirms their own observation, and that seems to be an important point, and this is something we will implement. So the application is in the development process actually at the moment. It's not finalized yet.
Okay, and on the other side, we do not have push notifications. It's not necessary, but we have something like an achievement system for participating, so they can rise up in levels, a little bit gamification when doing so, so that they can climb a ladder and see that they develop further.
Okay, and one final question about your original development decisions. Did you choose to develop in a hybrid or in native apps for different environments? And can you say something about the pros and cons of the choice that you made?
So for the media app, it was actually an important decision that we took at the very beginning. And the point is with the meteors, you never will install the app before you observe your first fireball. And that's why we have chosen a web application where you simply go on a web page and there you are. And the advantage, or one more advantage, is that you don't have to develop parallel versions of the application for the different operating systems. Of course, there are compatibility issues with the different browsers, and in a web application, not all of the sensors you might use of the phone are available.
Fantastic. Thank you so much for both of you sharing that case study. We're going to move on to the final two speakers in the session now. Next up, we have Sven Schade from the European Commission. If you can join me up on stage, please. Sven works in the Joint Research I want to say commission, but I'm so used to saying JRC, the Joint Research Center. And he's going to say a little bit about the ups and downs of application development, also specifically in the context of citizen science. Sven, over to you.
Thank you very much, Margaret. Do you hear me and do you see my screen? Is this fine?
We're seeing you and hearing you clearly, but we're not seeing your slides yet. But they're just coming up now. There we go.
You have some? All right. Brilliant. Thank you very much, Margaret, and also thanks for all the speakers so far. I think we already got a good impression of what can be done with apps in citizen science. So I'm coming here as part of a team working on citizen science and doing app development for the last 5 years or so. And we also organize some activities to discuss with people developing apps within the JRC. So we're in contact with people developing about 19 or 20 different mobile apps. So I'll speak a bit from this experience and also reflect on what was just told by the previous speakers. Before going on, and I hope it doesn't detort your attention, we will ask you towards the end of this session to share your takeaway message. So if you have some time towards the end of the session, please leave us just your main take-home message, your main thing you learned or you found surprising in the chat window. Thank you very much for that. When going ahead, if we look at the whole diversity of applications, we actually saw two great examples how to use apps for data collection. So I just want to widen here a bit the perspective that there are also apps you may use for different purposes. So data collection is certainly one, and I provide here some examples from our own organization. But you can also use applications to communicate about science, to basically reach people with mobile devices. There are apps which are more about education and learning, and there are some gaming apps that really help develop certain skills, which are interesting for citizen science as well. And last but not least, there are also apps which can be used for crowdsourcing, so also people not collecting data, but analyzing data. So I just wanted to widen this perspective a bit, because we heard about two apps which can be used to collect data, but there are also other functions that can be covered with mobile phone applications. What I want to do now is more giving a few words of caution to basically look at what is actually to be considered, or what may be worth to be aware of when considering the development of a mobile phone application. And I will do so by just giving a few messages that we frequently encountered and proving them wrong as far as I can. So the first one is really a message we sometimes receive, is that it's most important to develop a mobile app. So the main focus of a project may be to develop a mobile app. But that we already saw in the previous two presentations, what's much more important is actually the process around. So it's not only the technical development of an app, but there is actually much more to it, and especially the co-design and co-creation of apps ahead of a technical development, or actually in parallel, is equally important. So when thinking about app developments, don't only think about the technology issues, but also about the engagement of the stakeholders, the co-design process, and possibly also about the scope in terms of policy and what the app should finally do. A second thing we frequently heard in the past years was that it's enough to do one application and this will do the job. And in fact, we already saw in the presentation of Steve before that this is certainly not true. So an app is not a one-size-fits-all solution. And indeed, an app may support your data gathering or your data validation, but it has to be embedded in a larger process. I used a picture that we frequently use as a process, but actually you saw before in Stephen's presentation that there was an app, there was a validation tool, and there was a platform, and all were interconnected by a very deliberate process. So it's not only looking at the app itself and at the underlying infrastructure, it's also embedding it in a wider research process, which is very important. A third element, which we didn't come across in this talk, but in wider audience, sooner or later, there will be the question, yeah, okay, but the data that is collected with the app is not good enough anyway. So why do you collect all the data with an app? Friederike already talked a bit about the importance to collect data with an app in a meaningful way and to design it right. And you already saw two very good applications, or three applications, in fact, that you can develop apps in a way that the data is of good quality and it fits the purpose. And here I'm just adding one example of a lot of apps which are taking records for biodiversity, for example, eBirds, but also others, which actually contribute to the global biodiversity information facility. So this is actually apps providing input about biodiversity. And at the end, a huge proportion of this global data set is actually contributed by citizen science data, which is of high value and has been collected with a mobile phone application. And last but not least, I also want to mention this aspect. More and more we hear that we want to develop an app because mobile apps are the things that people do these days. So it may be worth to reflect if really a mobile application does the right job. It speaks a bit to the point we had before of having a native application or a hybrid application that is specific for operating systems, as compared to choose a web-based app, as Friederike and Sicco presented, where actually the technology is not really native mobile phone apps, but it's web-based and mobile-ready, which makes a big difference. So also here's a word of caution is, there may be certain ambitions in terms of functionality, but it shouldn't be the first intuitive answer to develop an app to meet the user needs. Also other tools like surveys or other online tools and web pages may do the job. So this is basically just a quick walkthrough also in view of time of a few myths that we came along in these last 5 years, and I hope I could respond to them. If you're interested in more and you have want to look at a few more scientific works which are dealing with this topic, here are a few starting points coming from our own work on data management. But also on the bottom right, it's the book which was published after the first EXA conferences 4 years ago. And on the bottom left, you basically also have the workshop reports of the workshops we had with Ulrike, Soledad, and many others in Berlin and in Gothenburg. So to close, just as a summary, when designing a citizen science project and having an app in mind, it's always very important to consider the wider context, which kind of people are involved and why should actually technology be developed. Then it is also very important to know the participants very well, and the co-design approach is certainly very valuable in developing technology that is then also used by people. And then it's also extremely important to handle the people involved and also the data, which may be personal data, very carefully. With this, I come to an end. You will have a recording and the slides afterwards, and I'm looking forward to any question. Thank you very much.
Fantastic. Thank you so much, Sven. We do have one question that's just come in for you, whether there's a difference from the European Commission perspective on apps to directly monitor things like e-health apps or serious game apps.
I'm not sure if I get the question perfectly.
Is there a difference in the perspective of monitoring apps or serious games apps? Is there a difference in how they're developed, or the question is asking specifically for the European Commission perspective?
Well, there are different flavors in here, and this is why I was asking. I think on the one hand, you have these apps which collect data in the background, and there is always a question about data ownership and who has access to the data. So there is certainly actually a big debate at the moment also who is owning data, and if the owner is a private company, how to get access of the data and use it also for creating public value and use it for citizen science. The very different thing is actually gaming, apps used for gaming. And there are some very interesting developments, particularly in Denmark, which actually try to replicate psychological experiments from reality into mobile phone applications to actually make tests about human behavior. But this is yet a much different story. But the main purpose is really the data ownership and access to data, which is a big topic also from the Commission perspective.
Fantastic. Thank you, Sven. And so to close off, I'd like to introduce to the stage Soledad Luna, who's a project officer at the Wadden World Heritage, and also Chrisa Tsinaraki, I'm sorry if I've mangled that, who works together with Sven at the European Commission Joint Research Centre. And they're going to share with us some closing reflections on these case studies of mobile applications for citizen science. Over to you both.
Hello.
So you start or do I start, Sole?
However you want. How did you like these?
Let's say that I have some reflections on what all the presenters said. First of all, starting from Sven, before developing a mobile app, first think if you really want it, if you really need it. You may want it, or you may want a way to interact on a mobile device, but it's not for sure that you need an app, and you should think twice, because it's not just the app, it's also all the stuff that should be in the background and the way that the community works. This is one thing. And the other thing is that, as Steve, I think, said, it's different to design for scientists and different to design for citizens. So we should keep this also in mind. Speaking about citizens, we should keep them at least informed and, in my opinion, and I think that you agree on this, always engaged, because if you let it go somehow and you don't remind them of the existence of the app or the whole framework that you have behind the app, they tend not to be that motivated and not to contribute. So we saw that there are different ways of doing so, like the WhatsApp group or a mailing list, different modalities, but still you have to keep them always informed. I think that the ideal way would be through the app to send some push notifications, so it's all in one package for the citizen, and he doesn't have to look at different channels. And to make it, to be able to make out something out of the app and the whole framework, you should always be somehow participatory in your approach and collaborating. And there are different terms in the different contexts. And if we go from the developer side, you should be agile and you should be flexible enough to take on board new requirements and to prioritize, etc. If you go at the society, you should always keep people interested in what you are doing if you want them to continue contributing, and they should always participate. So co-designing that we saw from Friederike's approach, or even participation, also including not only data collection, but also user testing, is the way to go. So on this, you can continue, and if needed, we can also interact with the people who are listening to us.
Excellent. Thank you, Chrisa. And we all are also very interested on what is the takeaway message that you all participants, got from this session. What I think the presenters emphasized is that we need to have a good plan. We need to have clear goals. What are the needs of the project, and see these wider context. We need to plan for all the parts of the cycle to have a good project and good results. Get to know your audience, get to understand their needs, and you can do this during the design, like for example in co-design as was presented, but also during the implementation. Maintain this two-way communication among other methods that you can use, and always let them know how much you value their participation, their contribution, their being there, their time. And always also communicate your expectations, and communication is always a challenge as well. Now we have to keep communicating and and when I say communication, it's in all directions, maybe, and be patient with that. And so when you see if we're talking about the same thing, or if yeah, we always still need to keep communicating and be prepared, plan for adaptation. Things might change, and plan B always works. And one more minute, what I wanted to say from your questions, I see that it's very important to trust, to build this trust with participants, and to be able to find what are past experiences, what exists already in the world. No? So then it's also good to register your project, your apps in the platforms that already exist. Everybody's happy to share and learn from each other. Thank you.
And sorry to intervene, but since we were talking about registering your project, especially for environmental monitoring projects, please have a look at the inventory that we are developing, that we are maintaining at the JRC, and register your project if it's not there already.
Fantastic. Thank you for that final reminder, Chrisa, to add your citizen science projects to the JRC inventory. We've got one too. Add it also to the EU Citizen Science platform while you're at it. Thank you so much to all of these speakers sharing these fantastic insights to mobile app development. The coffee room is about to open over on the social room on Zoom, and we've got a fantastic closing question. So I thought what I'd do is I'm going to give you the question here, and then please everybody go on over and have a chat over coffee about how you figure out in the first place whether to build an app or not. Do you have to do some co-creation and some co-design in the first place before it's even clear whether you go mobile app or you do something else, mobile web, physical, paper and pen? So with that closing question, thank you very much to all of our speakers, and we hope that you will join that discussion over in the coffee room in the social room. Thank you, everybody.